point here, which the top point on a wave is called the crest. So let's just go ahead and label that. The high point on a wave is called the crest. And the low point on a wave we call the trough. So we have the high point is the crest, and the low point is called the trough. And again, those things are already labeled for you on that next slide, okay? So high point on the wave is called the crest, low point is called the trough. But we want to label what the wavelength would be. And the wavelength is where I can start having a repeating type of unit, or a repeating wave. So once I get from this crest, I move down, go to the trough, and then I move back up and I've reached another crest. So because I've reached this second crest, it's like I'm going to start repeating that wave all over again. So once I'm at this crest, I move down, I go back up, I'm at another crest. And then I'm going to repeat that all over again. Move down to the trough, go back up to a crest, and then it's going to repeat again. Crest to trough, back to crest. So from crest to crest here, those are two equal points. That is what we would call your wavelength. So from crest to crest could be a wavelength. Or if I had a trough down here and then a trough down here, which I do, from that trough to that trough, that would also be considered a wavelength. Now, wavelength, we give a certain symbol, and you can see that next to where it says wavelength that's labeled on your slide. We give it a little symbol that kind of looks like an upside down Y, looks like this. And that's called lambda. It's a Greek symbol. And again, it's called lambda, and it just represents wavelength, okay? So that's why you see that little symbol there. The next thing that I want you to label is the amplitude. Now this line that I drew here in the middle, that's just the origin. We can think of that as like being the x-axis, okay? So this line that's here in the middle, that's just like the origin. So it's just like this wave is passing through the origin, or passing through kind of like the x-axis. So we have crest as being the top point of the wave, the highest point. We have the trough as being the lowest point on the wave. The wavelength is where I start having a repeating distance, or a repeating unit. So a good example would be going from like crest to crest, or from trough to trough. And amplitude is the next thing that I would like you to label. Amplitude tells you the power of the wave. So the amplitude would be the distance from the origin, or that x-axis, to the highest point on the wave. Or you could also say it's the distance from the origin, or the x-axis, to the lowest point on the wave. Those are amplitude. Amplitude tells you the power of the wave. So, for example, when you are listening to your stereo and you turn up the volume, you are specifically changing the amplitude. You're making the power of that wave much stronger. So let's say that at first your amplitude looked like this. So those peaks aren't very high. But then you crank up the volume, and now it doesn't look like that anymore. It looks more like that. So the peaks are way higher. The amplitude is much higher. So it indicates, amplitude just indicates like the power or the strength of the wave. And if we think about it in terms of sound, it would be like loudness. If we want to think about it in terms of light, it's like brightness. So the brighter the light, the more amplitude that light has, or that wave has, because it's so much brighter. And a dim or a dull light would be a wave that has a very small amplitude. So just kind of like power or strength of the wave. Now, frequency is that very last thing, and that's something that we're not going to label on your chart or on your little graph for your wave, but I would like you to understand that frequency is the number of waves that pass a point in 1 second. So let's say that I have, here's my origin. So I have all of these waves. So I could have from crest to crest, that's a wavelength. So I'd have, here would be one wave. So from here to here is one wave. From here to here would be two waves. So maybe in like a second, I had two waves that passed by in a second. Let's say that it has a lot of energy. So if it has a lot of energy, I'm going to have a lot of waves passing at one point, or in 1 second. So let's say in 1 second I have all of those pass. So let's see how many waves would pass. I'd have from crest to crest, so that'd be 1. From the other crest to crest, that's 2. From the other crest to this crest would be 3 waves that passed. This one to this one would be 4, this one to this one would be 5, and this one to this one would be 6. So in this one, the wavelength was much shorter than the other one, so I had more waves that passed in this second. So this one would have a greater frequency. So the shorter the wavelength, the higher the frequency. So if I have very short wavelengths, then that means I could have more waves that pass in 1 second. So let's actually write something like that down. I would like you to write down for me, the shorter the wavelength, actually I'm going to use the symbol lambda for wavelength. The shorter the wavelength, the higher the frequency. So these will also be inversely related. So the shorter the wavelength, the higher the frequency. The shorter the wavelength, the higher the frequency. Okay, so that takes us, guys, to slide number 6. And on slide number 6, we can actually calculate the speed at which that light is traveling. Or if we know the speed, we can calculate the frequency, or we can calculate the wavelength. Now, the speed of light has a specific speed, and actually Albert Einstein was one that worked on that, but we actually give credit to a guy named Albert Michelson. He was the one that had calculated it and won a Nobel Prize over that. So Albert Michelson is really the one that did this. But he calculated the speed of light, which we symbolize with the letter C. We calculate the speed of light as being 3 times 10 to the 8th meters per second. So that is our speed of light, which, again, we symbolize the speed of light with the letter C, and its speed equals 3 times 10 to the 8th meters per second. Now, if we wanted to calculate, based on speed, the frequency or the wavelength, there is an equation, and that equation is C equals F times lambda. C stands for your speed, specifically speed of light. F stands for frequency, and lambda stands for wavelength. So I have speed, frequency, and wavelength. So if I wanted to find the frequency, and you know the speed and the wavelength, you could find frequency based on this equation. So if I want to find wavelength, or if I want to find frequency, or I want to find speed, I'm going to use this equation here. C equals F times lambda, or speed equals frequency times wavelength, okay? Now, if you flip that page over, there are 2 practice problems that I have for us to do in class tomorrow. So this is where I want to end, because I think that we can do those together in class. If you want to go ahead and try them, I think that would be fantastic. And then we will continue with our light stuff tomorrow, because that got us about halfway through this PowerPoint. So guys, have a really good night, and I will see you tomorrow. Make sure that you wear appropriate clothing for our flame test tomorrow, okay? Bye, guys.